Hi, welcome back. This is Irfan. So last time we left off, we were planning on porting our game to our headset, but it asked us our program. It asked us to make sure that we have our phone, our headset connected, as well as in developer mode. And today I'm going to show you how to put the application on uh, developer mode. So to help show this clearly, what I did is I used Samsung DeX from my phone, Android phone. So you have a recently upgraded Android phone, you would have that program which just mimics what we have. Whatever application I have, it will show up on my PC, Windows PC. You have to connect your phone to your laptop or using USB-C thing, and you also need to download for the PC this Samsung DeX software for the PC, so it can display your screen. You can get that application by going to samsung.com/us/explorer/dex or just samsungdex.com, and then you can download it for Windows 7 and 10, which also works for Windows 11. So now that we have that installed, we can actually, let me show you what it actually looks like. So let me go ahead and open that up. So this is a pretty nifty tool for connecting to your phone to your screen, so you can watch the same thing. So on my Samsung DeX application, if you opened it, then it will ask you, do you want to transfer to a TV or monitor or a PC? Because I want it on a PC, I go ahead and click that option, and it will try to connect. And you should also have that application open here, Samsung DeX. So it's looking for it, and it's asking me, do you want to start it on my computer? So I would click start now on my phone. So here, the Samsung desk shows me all the files that I have on my computer and then projects it here. So if I hit apps, these are all the applications that are currently on my phone. But what we want to do is we want to set up a developer account on the Oculus device. So if I click here, so this is already downloaded, so if I click here, after installing, I might have to restart to enlarge it a little bit bigger. Okay, so this is my main page. So when I open up the Oculus account, I have here my device that I'm using, Quest and Quest 2. So if I click here, there's different choices depending on which one you're using. So for our purpose, it's Quest and Quest 2. Now, with it connected, I can click the menu icon here, and then if our if our device is connected, we can go ahead and click devices, and it will start searching for our device. And as you can see, the MyQuest 2 device has been connected, and here this is a picture of it, and this is my left controller, my right controller, and the bars here show the charge level, and this is the headset itself. Now if we scroll down, we get here with the Wi-Fi. We're going to make sure that it's on the same Wi-Fi. Our controllers, if they're not already paired, you can pair new controllers, but it's already done. I have my left controller, my right controller, so we're set for that. But we want developer mode. So developer mode is shown here. If I click that, it'll go to developer settings and then this developer mode. So we would have to slide the switch to start it on. Okay, so now that we know that it's on, let's go back to our Unity project and let's do a fresh new rebuild. We go to File, Build Settings, and make sure our scene is showing up. We're on Android. So our device is not, my device is not connected, my headset is not connected anymore because I took it out to do the Samsung desk because I didn't have an extra wire. But if I reconnect it, it will show up. So all I have to do is hit refresh, and then I can find my Oculus Quest 2. So this step is very important because what will happen is when you transfer it, it's going to see if it's connected and if it's in developer mode. So you want to make sure that this run device says Oculus Quest 2. So let's go ahead and build. This will build onto your PC first. So I created a folder of Fonziola, Star Wars Mock, and under a folder called Build. So I have my Star Wars Mock, so let's rebuild it again. So it's a fresh copy. So it asks me, do you want to replace it? And I say yes. So now we're waiting for that to go ahead and complete. Let us go ahead and open up. Let us go ahead and open up the here I'm currently trying to open up my VR side loader program. So I placed it under C program files and VR side loader. So you can place that application anywhere after extracting. So I double click this. So I drag and drop my APK onto here in this box, and now it says Star Wars Mock.apk is successfully sideloaded. You can now start your app. So here it has been installed, and I would have to transfer the video to my headset. So, last time we found out that so last time what happened was that when we tried to build the application or Star Wars scene and we sent it to the headset, we were unable to move the hands even though we were moving the controllers. So we exited that and then we went back to Unity. And upon inspection of our Unity project, there are a few things that we did forget to include. So one of the things is if we go back to our scene and under XR Origin or camera offset, you have three different kinds of controllers. We have the right hand controller, the main camera, and the left hand controller. So if you take a look at the main camera, it has a transform, camera, audio listener, and track post driver input system. So the track post driver input system allows you to track the head movements. So this is appropriately placed on the main camera because that's where the camera will be at, and you'll be moving and seeing things around the environment, and that's why we were able to do only that. But if we look at our right hand controller and our left hand controller, they're missing that component. So we need to add a track post driver to both of them. Track post driver input system. So this follows and uses the new input system. And let's add it for the other one too. Okay. So we do have to alter a few things inside this track post driver. So let us hit this triangle and expand it. Now this position input and the rotation input. So here we need to add the reference to using the controllers. So we can add an input action for the right controller. So we need to add a binding by hitting a plus and click add binding, and then we can double click the position. So we need to be able to create a path to handle the controller movement. So we are dealing with the right hand controller, so we need to look for that. So if we click here, we have to be under XR controller and then look for our specific controller. Ours is going to be the Oculus Touch controller. So let's click that. And since we're again using the right hand, we're going to click up here, Oculus Touch controller, right hand. And we need to then select device position. So that's going to handle all 6 directions. So with that path already there, that's going to control the right hand controller, track it. We need to do the same thing, but for rotation. So let's click plus and add another binding. So we need a path. Then we go to XR controller. Or touch controller, Oculus. Again, we need for the right hand controller. But this time, instead of device position, we need device rotation. So if the controller actually rotates, we need to track that as well. Let's change and add that to the left-hand controller. So we're doing exact same thing, but with the left-hand controller. Plus, add binding, double click, path, XR controller, touch controller, Oculus. We need left hand. We need device position. And then rotation, we need rotation. So let's go ahead and add the rotation part for the left hand. Add binding. We need to add the path.
From the side, a kid called out, "Go, Gene, go!" And too surprised to even shout, Gene jumped in with Katie Sue. "I like cookies, I like tea, I want you to jump with me." The rope whizzed, slapped.
Okay.
Faster, faster.
So let's go ahead and save that. So both have track price, pose driver. We also need one more thing, and that would be on the XR origin. So XR origin actually needs
the school bells ringety ring, those two girls race singity zing out the classroom door. Gene doesn't push kids and smooch
input action manager. So this controls the all the input actions that happen, like click, rotate, position, move position of the head. So this is all being tracked. So we want to add this action asset. So this action asset is this lightsaber controller input actions that we created down here. So let us go ahead, go back here. So we want you need to know that we're using this mapping. So we have to click plus, and then drag and drop this here. And then let's save it. And we want to also make sure that the tracking origin mode on our XR origin is set to floor, because this is our floor and we want it at the bottom.
Main character. What does main character mean? You can tell me, what does main character mean? JJ, you want to give it a shot?
So if we go ahead and build it, save it, and build it. So again, our Oculus Quest 2 is showing up. Let's go ahead and build it.
It means when it says main character.
So let it go ahead and build.
They're not nice. They're not nice. I'm not asking about me, Gene. I'm asking, what do you think main character is, so we can answer this question. What do you think it
So
means?
our build happened again. It completed the build. So let's go ahead and drag it to our VR side loader app.
Go ahead, ladies.
Oh, okay. So this warning that you see here means that the my headset is currently connected, but it may not be powered on. So let's go ahead and make sure that's
It
on.
doesn't matter what they look like, how they act, what they do. It just means the main character is the person you're following in the story, right? Everything we're gonna learn about is about that person. So who is the main character in the Recess Queen? Was it Mean Gene or Katie Sue? Who was being followed in the story? Who did we understand the perspective of? Mean Gene or Katie Sue? If you think it's Mean Gene, you're gonna put Katie Nice.
Okay, so I connected up my USB to my headset, and it's charging currently and powered up. So let's go ahead and try drag and drop it again.
Because she doesn't have a friend.
Okay, now the Star Wars Mock, the APK has been successfully sideloaded. So let me go ahead and switch it to the Oculus view.
Now here's where we're gonna have our partner. So you are gonna talk to your partner about the Recess Queen's character traits at the beginning of the story and at the end of the story. So how would you describe
Hey, Matthew! Hi.
So as you saw, the hand started moving again because we added the
I'm gonna do the beginning story.
track post driver for each one of them.
10. I
Now what we need to do,
the beginning of the story.
Now-
Can we just start now, Matthew?
now we need
I
to
wanna wait to
figure out why the sword was not showing up. So
I always
let's go ahead and do that.
closer.
So the reason why we're not able to see the sword when we go into the headset, but we can see it on our Unity program, is because if I select the Obi-Wan lightsaber and I take a look at this transform, See, it's continuously dropping and going negative, negative, negative. So that means gravity is undertaking it because we have this rigid body component. Rigid body component, if we click here, it's actually using gravity. So if we take that out, it would actually stop moving. It won't take an effect because we're in certain play mode. But if I take it off, shut it off, and then take off gravity, then it would actually stay in position. So currently it's at 0.27. So after hitting play,
In the end of the story,
it did not move. See, the sword is still in position.
Matthew, was in the beginning of the story, was me and Jean me? Yeah.
No, Mindy, the ending, Mindy was kind. Mindy was kind in the ending.
See,
of the
if I-
story. I'm like, oops, what's
If I
that?
zoom in on play mode, then it's actually, here's our hands
This one? Okay.
right here,
Kind in the beginning of the story?
but the lightsaber is slightly above.
No.
So it
Was she
I was
moved
thinking-
upon play.
selfish in the beginning of the story? Yes.
Waste that.
Sorry. No.
So to fix this, we can again go to the rigid body and make it kinematic. Check is kinematic because we don't want this whole piece to be affected by physics forces. So if we click this kinematic, the only way it would move is by using code. So this has nothing to, if I click this is kinematic, then the sword will not move by physics, it will not move by the physics engine of Unity. So I click there, is kinematic. You only want this checked, unchecked. You want to use is kinematic false if you are trying to create collisions and trying to, like in a car crash or something, then you would want to use physics. You want to see cars flying properly according to physics. But because this is sword, there's no real, it's going to be mainly in your hand.
I'm putting this.
So there should not be any physics applied to this. So if I click that,
I know who's putting. At the end of the story,
or the scene,
she was friendly. Thank you.
Very nice.
And playful. And kind. What the? What the? Hey! See you later.
Alright, my friend. Who's ready for a dance party?
so let me actually set it so we can see it a lot better.
Breakland, turning red freeze dance. Guacamole. When the music
I set the Y coordinates to 0,
that you see or do your own. But when the music stops, you
but it's colliding with this, so let's bump it up to 0.5. So switch to game mode, you can see the lightsaber properly. So now let's hit play.
freeze.
Baby, what's that sound?
of your homework.
If Grandma catch you, you're supposed to be working.
Since I changed the Obi-Wan lightsaber to up 0.5, I want to get a good glimpse, and so I wanted to change my XR origin up to 0.5 as well. So if we were to look at it in play mode,
Freeze!
Malin, dear, what's that sound?
see, showed. So let us go ahead and close this.
Freeze!
Aren't you supposed to be working in the temple?
Let's go ahead and save it. And now let's try one more time in the headset. So we saved it. Let's go ahead and build it.
Freeze!
The panda inside you is strong. Nice. Have fun, right? Okay, before I let my friends go, I want to ask if this is okay. Miss Hannon will start, okay? Hold on. When I start, then we can all start together. His name, hold on, when it comes to his name, let's say happy birthday to, can you guys say Robert?
No.
Robert.
Okay, let's go. I can drop it.
I think Robert.
Robert.
That's a bad word.
Okay, so it successfully ported, sideloaded to the thing.
Hi.
Let us go ahead and we'll switch it to VR mode.
Hey guys, it's going to Drummer again and welcome back to my channel. So today I'm pretty excited because I'm going to continue the video.
Okay, so one of the things that we need to do is make sure that the objects that we're grabbing, like for example our lightsaber, has a rigid body as well as the colliders. So we can create a collider for the Obi-Wan blade because that's where the damage is going to occur. So we go to Obi-Wan Kenobi lightsaber and we click Obi-Wan blade. So if you notice that only the blade itself is selected, so all we have to do is go ahead and add a component and look for capsule collider, because the blade represents more closely to a capsule. So let's go ahead and pick that. And you can see the capsule is a little bit big, more like a spear. This light green outline here. So we need to adjust this capsule collider so that it fits more snug around the blade. So to do that, in the capsule collider, we need to hit this button where it says edit collider. So now we can change the shape of it. So we're going to leave the center the way it is, and the radius is fine because we want it to go this length. All we have to do is change the height. The height is a little bit too big, so I can drag this Wait, we also have to make sure that it follows the X direction. So if we reduce the height, actually I'm sorry, Z axis. So we're going to go Z axis. So now Z axis means it's going along the length of the blade, which is what we want. So we kind of match the ends of the capsule collider with the ends of the blade. Now we want, this is the radius, now we want the height, the radius of the cylinder. So that has to be small. So we can drag the word, shrink it down as much as possible. Okay, so that looks a lot better now. But so now this is when we need this collider. So when we're doing actual fighting, then this collider will collide with enemies or objects, and then it'll do physics. So since we want to do physics with that part of the sword, we don't add its trigger. So we leave that on the blank. However, so we need to create another capsule collider, but for the handle itself. So whenever we are using grab interactables and we want to grab a particular area, we want to make sure that this is this capsule collider is a trigger. So wherever you want to grab the object, you want to have a trigger. So let's go ahead and we can actually select the whole blade, and we can create a capsule collider for it too. Let's minimize all this, and let us go to add component. So we want add component. So we actually want to first create an empty game object for this lightsaber, for the handle part, just like there's a separate piece for the blade itself. So to do that, let's go ahead and right click on Obi-Wan Kenobi sword, the parent, and we would like to create an empty. So this empty we will call handle, or actually it's specifically called the hull. So the hull is actually further down, so we want to move this toward the center of the handle. And this is where we want to create a capsule collider. So let's go ahead and create a capsule collider. And we need to edit the collider again. So this has to be, like I said, it has to be triggered so it reacts to our rays. And now we want to also adjust the size. So again, we want this to follow the z-axis, and the height of it will be greater than 1. So you see the green arrow. So right about there to the end points of the hull, and we want to increase the radius just a little bit so it covers the handle itself. And this is also going to require a rigid body, but the rigid body does not use gravity, but it is kinematic. We want to change the collision detection with continuous dynamic. That means it will continuously check if there's any collisions. So now that we have that set up, let's go ahead and overwrite this. Actually, let's drag this Obi-Wan lightsaber into a prefab. We're creating a prefab because we already pretty much got the model down for Obi-Wan lightsaber, so we just want to be able to reuse it. Because let's say if you used it once and then you drop it and then another one comes its way along the game, then you have a chance to pick it up again. It will spawn again. So that's why it's important to go ahead and create prefab of it. And we want a original prefab. And down here you see a prefab. So anytime we want prefab of it, we can spawn it again doing scripts. So let's go ahead and save this. And test it out. Hello and welcome back to our Unity tutorial using the Star Wars mock game. Let us continue. Last time we only had a plane, but I decorated it with this marble type floor. You can get that if you purchase or you get from the Windows Asset Store. I provided a link for that in the in the documentation. And when you get that, it's gonna be, if you go to Package Manager, once you download it, let's refresh it. Let's see. Hold on one second. I think we have a sign-in problem. Let me sign in to Unity. Okay, so I signed in into Unity. That's why I was showing empty in the Package Manager. So let me click Package Manager. Okay, if you have downloaded the correct package from the list, that will be this one that says PBS Material Variety Pack, and you get a whole assortment of materials that you can use for your project. One of them is so you could go ahead and install it into your project, and you get different materials like this asphalt, bark, material, glass, but this particular one is actually found under metals, and I believe it's this one, metal 2. So I just dragged and dropped in and I got this nice looking ground. And now, so what I also did is, since last time, is I created this white table for all the objects to land on, including our sword. This is our sword, and last time, what we did, if we look at the sword, Obi-Wan Kenobi sword, if you remember correctly, there was the Obi-Wan blade. There was a spot where it's supposed to hold, where we set it for the collider to hold onto, and the whole handle, including the hold spot. So each one of these has a separate box collider with the trigger off, because you want the collider, the hand collider, to interact with each part of this. So I have one for hold spot, a box collider, and for the blade I put a yellow capsule. So normally in Star Wars movies you have like a little glow on the blade itself. So what I did is, in the material, I selected standard shader, and then within standard shader I changed the albedo color to a yellowish, a specular, so it brightens and looks nicer. And I also made sure that emission is checked, and then I made it even more yellow, HDR version. So that is what we did last time. Now the only difference is, remember we have two audio sources, one with the lightsaber turning on and another one turning off. And we had an animator, which is the Obi-Wan lightsaber. So this had our blade on and blade off. And we programmed this to work on a button, which I will show you in a minute. So then we have our rigid body, which is only has use gravity, so whenever we let go of it, it will fall down. And its kinematic is off because we want some interaction with it. And when you do that, you want the rigid body to be attached to the parent game object. So we put it only on this one. So even though these have colliders, we want the rigid body to be attached to the main parent one. We also added to this, we added a damage script. So in this damage script, so let me go ahead and open this up and show you what that is. So because this is a physics collider, we had to create a particular script, so anything that gets hit by the blade will be affected when it collides in it. So it's one collider attacking another collider, so that's what we have to do on collision enter. And in the parentheses is collision, which means the interaction. So this collision knows exactly everything about what happened during that collision. So between the sword and another object, that's a collider. So inside here, we use this call object here to figure out if what I hit has a tag that says enemy. So call.gameObject compared tag is enemy. So this energy enemy tag is actually, go back to the Unity, so for this I created 3 new objects for us to work on to attack the blade. So I created 3 new objects. It's called the spear, a cube, spear, and capsule. Okay, now each of these I set a tag for enemy. So anytime this blade attacks either the capsule, the spear, or the cube, then it's going to be affected by the blade. So it looks for this object. If it works, if it hits the right target, then it will be affected by the collision. So going back to the script, so if our blade hits something, collides with something with the tag enemy, then we call the rigid body of that enemy object, and we do that by doing call collider game object get component rigid body. So we within that collision we got its rigid body, and then we gave it an object name of RB enemy, rigid body enemy, and from there we applied a force to that enemy. So RB enemy dot add force vector 3 forward means it's a shorthand way of writing 001, vector 3001. So in our case, it means whichever way we're hitting it, that's the direction it's gonna go, forward direction, in the positive Z direction. And we multiplied this by a float variable called force multiplier. So that float multiplier, I said it would be about three floats. But if you want like a little dramatic effect, you can increase this, or if you want it slow, you can make it like 10. You can make it 10 or 2 or 1, whatever you like. And this other parameter is the force mode. So force mode.force means it adds the continuous force to the rigid body using mass. So depending on how big the game object is, it's going to use that force. So in our case, most of the game objects are usually, if you go back to the rigid body, is usually 1 kilogram. So it's going to use that times gravity to calculate the force. So I can make it slower or harder if I want by changing the mass here. So this is what we have, and we attach this script. We have attached this script to the main game object, lightsaber damage. So we attach it to the parent. Okay, and let's move right along. Minimize this. Let's grab some room. Okay, the next component, if you remember, is we added a XR grab interactable. And what that does is we included it detected the XR interaction manager, so any interaction between the interactor and an object, this is managed by this script here. So you have to make sure it's there. So we created another game object, XR interaction manager, and we kept it there. So we added this game object, and then we imported using add component, XR interaction manager. So this file, what that does is it controls how the interaction occurs, how, when, and where. Okay, going back to this one. And so now this interaction layer mask, so there's different layers that this would interact with. So there are different options that we can choose. We can choose that it interacts with nothing. We can choose that it interacts with everything. So if we do everything, then that would include things like even this table. So I can basically grab the table as well. So, which I don't want. I want the table to remain stationary. I only want to interact and grab the things you see on top of the table. So that's why we have to kind of control what is grabbable, what is not. So, and this interaction grabbable, so this is set because I only want to interact with things that are grabbable. So this one is interactable, as well as the spear. It also has a grab interactable. It's right there. And it has a capsule. Also has an interaction layer mask, which is grabbable, and etc. As well as the lightsaber. Now this is important because when we go inside our XR origin, where our hands are, so the left hand controller, it has an XR direct interactor, which means directly we can grab these objects by our hand. So we have to make sure that it looks for things that are grabbable, the grabbable layer mask. So that's where we also select the layer here. So the same thing for the right hand. The right hand also has the layer mask called grabbable. And we also have to even make sure also that our interactive rays have the same layer mask too. So it's grabbable. And also the right hand interactor, also grabbable. Okay, so what would happen is, let's say if the right interactor and the left interactor are both grabbable layer masks, but let's say the sphere was not. Let's say I change this to default or something else or nothing. Then what that means is I would be able to interact and grab with the ray interactor with everything that you see here except the sphere. It won't show up. It won't interact. It won't change colors on the ray. The same thing with the hand and vice versa. So we have to make sure that we're grabbing the right things. So that's why that becomes important. If you don't care, if you want to grab everything on scene, then it makes sense to either put everything or default. But if you're specific on what you're trying to grab and interact with, then it's better to be specific. Now, this attach form, so if we're going here to our left hand controller, so attach transform on the direct interactor is exactly what, if I'm grabbing something like the sword or the spear or some game object that's also grabbable, then I want to know what position it should grab. So I can indicate on the particular hand a particular spot. So I can add another game object here and say it's hold spot, like I did for the sword. I create a hold spot, and then I can drag and drop it, and it will always stick there. So that's, if you don't mind, if you don't care, you just want it to be left hand controller. If I do that, then it will attach in the center of your hand. So if you want to be more specific, you want to create a specific spot for that. Same thing for the attach transform on the sword. So the attach transform, so I create, actually same thing for same thing for the left hand as in the right hand controller. Next thing that we had to go through is this in the right hand and left hand controller. So there's the select action trigger. So there are many options here. There's a state change, there's toggle, and there's sticky. So by default it's state. So it depends on the position. If you're hovering over the ball, then you automatically grab it. Or if you are like just barely touching it, or if you just entered it, or if you just exit it, then you can control all that with the state. State change is also if I'm putting my hand inside, and then I leave it, then it will actually select the game object. Toggle is like I can push a button and then it will turn it on, and if I push it back, then it'll turn off the activation. Same thing for sticky. It will stay on your hand until you press some buttons. So I decided to do sticky because that becomes easy. I only have to press it one time to get rid of it. So let's continue on, and then we have a sphere collider. The sphere collider is this ball that you see here around our hand. So here's our left hand controller in the center of this spot. So it has a sphere collider, and we have to make sure that it's set to trigger is on, because what that is if that's not on, then whatever it grabs, it will bounce off. And we don't want that, because we don't want any interaction between this collider and another collider that we're trying to grab. Okay, so now that we got our, now that we're in our headset, this is a particular virtual environment. There are different choices you can pick to whatever suits your wants and needs. So if you go to here, it's a menu. You get the apps menus here, and you have different choices. These are apps that are installed, including YouTube VR. But the most important things are your settings. So in settings, you want to make sure your Wi-Fi is set, and your Guardian. So your Guardian is once it's been ported, then you can set a safe boundary for you. So when it's ported already to your headset, you would draw a boundary for the area that you're going to be playing, and then you can unhook your USB, use it. Personalization, here this is where you can choose the different virtual environments. Like I have one here. So I click that, and I believe. Hello, hey, hello, welcome back. Last time we left, we had our sword, and we had just a plain floor. But we're gonna go ahead and add a few more things. So what I did is I got this material from the asset store, and I'll show you where I got that. And I added 3 different shades with different materials, and including our sword. So first off, and I created a little table. So first off, let me show you where I got this material from. So if I go to Windows, Package Manager, okay, so this is all my assets. So if I scroll down here, let me see, where is that one? Okay, PBS Material Variety Pack. So this is where I got all this material. And let's go take a look at it in the asset store. So okay, so here it shows it was $4.99, but you get all sorts of different materials. Like you see the brick, you have grass, you have metal, you have glass, you have all sorts of materials that you can use for a small fee. So $4.99. So you can go ahead and purchase it and download it. And I believe they may have a freer version with limited amount of content. Download a free demo material. Okay, so that's where we got and the material from. So you just have to download it and import it into the project Unity. And then all I did was just place it on top of the floor. So it went to the mesh render. Same thing what I did for the stone, and I put a materials on the cube as well as this. For the sword, this yellow tint, what I did is I went to down here to the Obi-Wan blade, and it has a mesh renderer with a material called yellow glow. So on yellow glow, if I go here, the shader, it's a standard specular setup. So we have albedo and specular as well as an emission color, yellow. So that's how it shows up, that yellow glow. Okay, so now that we got all of our things down and set up for us, we want to talk about scripting. So I want to be able to make sure I can grab these and use it for weaponry or using the force on them. So let's go ahead and talk about that for a second. So to do most of the interactions and to make sure that the Oculus Touch controls would work, we would have to have created a input system, which you'll find in, if you hit plus, go to XR, you go to inside assets, go to input action there. So you get this. So for our lightsaber itself, so let's take a look what the lightsaber entails. So if I double click it, this is kind of what the input system looks like. So first of all, we have to define an action map, and I named it lightsaber because this is the input system that I want to use for the lightsaber. And the actions that I want it to do is to either toggle on or toggle off. So in both cases, so you have an action type button. So both of these are button states because all I want to do is press a couple buttons and then it should work. Okay, so we don't need to do anything else for this. So if I click in here, for example, the toggle on. Now I wired this toggle on action to the primary button on the right hand Oculus Touch controller. Similarly, I wired the toggle off action to the secondary button. So what that means is this can only work the way I programmed it and set it up is only on the right hand touch controller. If I hit the primary button, which is the A button, then I turn on the lightsaber, and if and here the secondary button, if I hit the B button, then that would shut it off. So how do you set this up? So if I click here, this is actually a binding path. So if I click here in the path, I can click inside here and I get 3 usages: a track device, XR controller, XR HMD. Now, because we're working with the controller, you want XR controller. So if I click here, now these top ones are okay if you're working for general, if you were trying to program the controllers for not just the Oculus, but other handsets, then this will work fine. But since we're specific on an Oculus Touch controller, there's options here. So if I click that, then it goes even more specific. So Oculus Touch controller, we have the left hand and the right hand. So I want the lightsaber to be activated only on the right hand. So when I click here, now I get different options here. So for toggle on, I chose the primary button. I want the A button to turn it on. Okay, so that's why I picked primary button for the right hand side. Similarly, for the toggle off, the secondary button, so how I got that, pick the path, and I went to, again, Oculus Touch controller. Okay, Oculus Touch controller right hand, and here I want the secondary button. So in other words, on the right hand controller, the one labeled B. Okay, so once we got that arranged and figured out, then all it means is using our code to refer to this and create this kind of action, so it will work in our game. So let me change this. Let me go ahead and reduce it, put it aside here. And so let me go ahead and pull up the script that was done to side by side, so you see how the scripting was done. Let's see. So if I go to my scripts folder, I will see lightsaber. So I double click that. Visual Studio will open up. Okay, so first off, we need this is the using system, so this is by default. These four here are default listed when you start a script. So we had to also include input system because we want to have access to that file there, and input system interactions and the toolkit. We want to be able to interact with things like the input action asset, as well as the ray interactor and the hand. So we need these two files as well. So these files are very necessary if we want to program for any interactions with our game and the controllers. So starting off, so this is going to be a mono behavior. Okay, that's not going to change. So this is lightsaber, and we need first a reference to a lightsaber anim, because we need to tap in and use the animator that we created earlier with the lightsaber on and lightsaber off. So we have to have access to that so it works as soon as we press a button. And we also need to have reference to the audio source, the two audio sources included, lightsaber on and lightsaber off. So the actual sounds that was used. Okay, and we also need to get a public input action asset. Give an object name of lightsaber input action asset. So what this is the script is having access to this file, the lightsaber control.
Daddy was doing hair Henry.
To this one.
You were doing Henry.
So we need a public access to that script, and we got that by, if we go back to Unity, let me see if I can close this out.
Daddy, doing Henry.
Okay, so if I go to here and I go to my lightsaber script, which I attached to the lightsaber parent, you notice here that I have the lightsaber input action asset. So I drag this file onto that spot. So now we have access to it. And so within that, we need access to both of those actions that was listed. So the input toggle on and input toggle off. So toggle on action and toggle off action. We also needed public access to the X-ray interactors for both hands, right and left, because we want to be able to control whether the action, whether we have the lightsaber in the right hand or the left hand. So that's why we need the interaction from both of those, and we got that here. So if I go back to a lightsaber, the lightsaber script, so we have the right interactor and left interactor, and that came from here, my XR origin. So left hand controller, and this one, left ray interactor, and the right ray interactor. So each one of these has that comes within X-ray interactor. So this is the component that it's looking for. So we dragged and dropped it into that area, and we're trying to pull from each one of them this component, XR ray interactor. The reason being is because we would want to manipulate through code some of these factors, like force grab, attach transform, and some of these interactive events. So we need those in the script to make the whole thing work. So moving right along, and then input action map. So action map asset. So once we have gotten access to that document, lightsaber input action asset, we then need to access the action map, which is this one, the action map. So we called it lightsaber. And so each one of these within the start method, we had to define. So the lightsaber animator, get component animator. So what we did here is in the lightsaber, this is where the script is, but it's also where the animator component is. The same location. So that's why we were able to just say get component animator. Same thing for the lightsaber sound on and off. So we were able to just say get component audio source. So we go back here. Our script is here. We have our two audio sources. Here's the lightsaber turn on and the lightsaber turn off. So both of those. So now we have both of those defined. In our awake method, so the difference between the start method and awake method is that start happens. Okay, so now in awake. Okay, under awake method, we have action map asset. So we're looking for this action map lightsaber, which is found here, the action map. And then we're accessing all the two different toggle actions, toggle on action and toggle off action. So this comes from the action map asset, find action toggle. So what that's doing is we're going through here to action map and accessing toggle on and toggle off. And so we want this to occur whenever we press the button. So that tells us in these two lines, toggle on action dot perform, that after it has been pressed all the way, we're going to call this lightsaber on. And we want to make sure that this has been enabled so it knows it should be on and working. Same thing with toggle off action. We're looking using the action map asset to find toggle off, which is here, toggle off. Then again, so once the toggle off button has been used or activated, then we're doing this perform method. So when it's performed, when we push the B button, this method lightsaber off should go off. We want to make sure this action is enabled and will work whenever we press the button. So let's take a look at both of these methods. So lightsaber off, so what that will do is we have a private void lightsaber off, and as parameters we have input action dot callback context. So this parameter here, it gives us information about if there was any inputs that happened, and was there any communication between our controllers, our script, and the input action map. So we get the information using this variable context. If context.action.name is toggle off, so we're trying to make sure that this one is being activated whenever we push the B button or the secondary button. So when that happens, we want to call this method lightsaber off. Okay, the same goes true for the lightsaber on. So we have input action callback context. So it got information. So whenever we use the primary button or the A button, we're making sure that the action was actually called toggle on. So we have toggle on here. And we want to make sure that that's actually the right button that we're using. That's the right action. So when that happens, we have a we're activating. We're going to this method, lightsaber on. So what lightsaber on does is it first checks to make sure about the sound. So if the lightsaber sound on .clip.name is lightsaber turn on, which is the name found on the lightsaber turn on, exactly written as that in quotes. If that is the right clip that's playing, and if it's not already playing, that's what this not operator means. If it's playing but it's not already playing, then let's make sure that it is playing. So lightsaber sound on .play. So And same thing for lightsaber off. If lightsaber sound off, that clip, that name is lightsaber turn off. So in here, go back to lightsaber. I'm going to make sure this one is playing. This is the one that is activating. So if that's the correct lightsaber sound, audio source, and if it's not already playing, again, the not operator, if that's not already playing, then let's go ahead and play it. Lightsaber sound off dot play. Okay, so now in addition to having both of these turn on and off, we also, the sounds, we also need to make sure that the animation also works too. So that's why I said we have to have access to our animator. So lightsaber anim for both of these. Now we're doing a set bool because if you remember in the animator, let's go ahead and close this. If we remember correctly from the Obi-Wan lightsaber, our animator, Obi-Wan lightsaber, look like this. So it's being controlled by a bool. So if is on is true, as we stated here, then it'll go from blade off to blade on. If it's false, then it'll go from, it will set is on to false, and it'll go revert back to blade off. But by default, when the animator starts, when the animation happens, we're going straight to blade off. So we have to track this parameter here. So when the lightsaber is turned on, then we have to make sure we set the bow is on to true, so it follows this path. And if it's false, if it's on is false, we're going to make sure that it shuts off. So we travel down this path. And that's pretty much how the lightsaber activation on and off would work. So to see this in action, we need to actually go and turn on our headsets. So let us go ahead and okay, we're back in our environment, so let's go ahead and play this Star Wars mock. Click here under unknown sources. Okay, so here's our environment. We have our 4 items that you saw in Unity. We have the sword, we have our capsule, we have our spear, and we have our block. So let's say if I'm pointing to the block, see it's already shown I picked it up. So grab, if I aim both of them, I can pull it toward me like I'm using the force. So that was part of another script. So if I hit the trigger button, both hands, I'm just tossing it. I can also throw it away. I can actually also grab another item, let's say the spear. Let's try the capsule. Pull it toward me. Grab. If I double click on the trigger button in the right hand, this is where it shows up. If I double click on the right trigger, that's where it shows up. That's what happens. So I can let it go. Now let's try to aim for the sword. So if I aim for the sword, both double, I can drop both of them together. Looks like I'm using the force. When it comes close, I can actually grab the sword in my hand. See, it's in my hand correctly and I'm holding it. Now let's say it's in my right hand. So if I hit A, there you go. My sword has been activated and I can actually hit some of my other objects. Put it back here. You see there, it's actually interacting with my sword. And if I wanted to shut it off, it's actually close back into my hand. Okay, I grabbed it on my left hand. But if I want to shut off the lightsaber, I still would have to use the right hand controller and hit B. You see, it's shut off. Turn it on, and shut it off. So I can also drop it. So let's exit out of here using the menu button, and we quit the program. So go back to the Unity editor. Okay, so that was a quick demonstration on how the lightsaber on and off works. But let me quickly show you how we got the grabbing to work. It's very similar to how we turn on and off the lightsaber. The grabbing, we had to use a different input system. So let me go ahead and open that input system. So this time I created a new one called Jedi. So let's do that. Open this one up. Okay. So I created a new input system for the Jedi, the player. And I created an action map player. And I created, from this action map, I created 4 different actions. One to create lightning effects, one to hover, one to grab, and one to release. So all of these are going to be similarly activated by a button. So again, when we press a button, the only difference is on the hover, the grab, and the release. In addition of using action type, we had a button, but we use interactions to differentiate between the two. So every time I hit one time, so I use grip, the left hand and the right hand. So we have, for hovering, I use the left and right hand, so depending on which one I have it under, we have the left hand controller, and we have what's called an interaction. So every time the left hand or the right hand here's a tap, it's gonna do this hover action. Every time we do a grab, we're going to do the grip press for the right and left as well, but it's going to use a multi-tap interaction. So anytime I do a multi-tap, I'm going to actually grab it in my hand. And then finally, we do release. So again, either left or right hand controller. For these, we have a triple tap. So the interaction, every time I hit it 3 times, we're going to release the object. So let's go and quickly see what the script for that actually looks like. Very similar to the lightsaber. So the script will be under player attacks. So pretty much the same libraries we used for the lightsaber, pretty much the same input action, the same public input action asset. And these are all still getting the left interactor, right interactor. So this is coming from the rays, and these are X-ray direct interactors, right hand and left hand. These are coming from the actual hand. So the hand has direct interactors, while the ray has a X-ray interactor components. So here's some float values: a hover height, hover speed, hover range. So we need these when we are hovering the object above our ray. And we have a force multiplier, so we call it 4F when we actually release it. So what we did is, in start method, we wanted to define all of these: the left ray interactor, right ray interactor, left hand director interactor, and right hand. So we did this through a for each method. We loop through each of the children for this game object. So in other words, we're in XR origin. So this is where player attack script is found. So we're looping through the children to find the left hand controller, the right hand controller, and from there we need the direct interactor as well as the corresponding ray interactors. So that's how we define each of those things. Again, in Awake, we had to find the player action map player, which is this one. So player action map is called player, and from that player action we found these actions: the creating the lightning, hover effects, the grab, and the release. So again, to use the action method performed. So for example, the hover, for the grab, let's take one of these for example. So when we perform the grab object, when we double clicked, then we call this method grab object, and then we enable that action. So grab object again has the input action callback context as an argument, because it has information that we need to interpret the interaction. So we had to verify here if context.action.name is equal to grab. So we go back here, we have to make sure that this is called. Okay, so if that is called, if we double clicked it, then we want to find out if the ray actually hit something. So if we're actually touching something, so that's what we did. If left ray interactor or the right ray interactor gets a raycast hit, And from this out hit, we get information what the ray was actually colliding with. So when we use that to get the game object of the thing that was collided, for example, the sword, the spear, the cylinder, etc., the capsule, all those objects. So we're getting the game objects of those things. And then once we got the game objects, what we want from them is the XR grab interactable. So going back to Unity. So let's say, for example, the cube. The cube contains actually it has this component, XR grab interactable. So this is what we want, because we want to be able to use these interactable events. So we got XR grab interactable, and what we want is, once we have selected that object, like for the right hand or the left hand, if we entered it and entered the game object, we selected it, we want to call this method selected. So we have an add listener to listen to whenever we intersect it with that object. So what that does is we're going to go to the selected. So private void selected. So this select entered is actually, so if we go back to left hand controller, so we're actually tapping into this interactor event. Select entered event args as a parameter. So we could plug in from here, but this is the way to do it if you're doing straight code. So if you're doing straight code, left grab interactable dot selected enter. This line is similar to adding a new select entered event and then finding that method. So there we have to have a method on a script to locate it, but we don't need to do that because this line is basically doing the same thing. So what selected method does is so this select event enter event args. So this args argument has information about what object has been interacted, which object has been selected, which object is doing the selecting. So, but what we want is the object that was selected. So that's why I did args.interactable object. What do we want from it? We want the transform.position. We want the current position of that object that we picked, because we want to make it move toward us. So we're implementing the force. So the effect that you saw, that the object floating toward us when both beams are pulling toward us while we're holding both the grip buttons, that is done with this line using a vector3.lerp. So we have vector3.lerp uses 3 arguments. The current position of that object, so using the args argument, args.interactable object.transform.position, to go, this is the final position, transform.position, the final position, and some time factors, or time.delta time.hover speed. So time.delta time is the interval in seconds from the last frame to the current one. So we use the built-in time.delta time, and we multiply that by the hover speed, how fast it should come toward us. So that is a public float value that we labeled up here. So we can make it even faster or slower by changing this value here. So once that is done, once we have moved the object, we can now say that if it's close to the left ray interactor, we can turn on this use force grab and set it to true, or the right ray interactor to use force grab. So where this is located is, if we look at our interactors, so right ray interactors, and within the X-ray interactor component, you'll see here force grab on both of them. Force grab, force grab. So what that force grab means, it's going to move the object to your hand rather than interacting with it at a distance. So that's how I was able to grab it in my hand, all those objects. So currently they're set to false initially, both of them. So but once it's selected, when it's close by, we can then now say we set it to true. Only during the time while it's interacting with the XR ray. And then we have the hover object, so you can look at that at your leisure, but the same idea. We're getting a raycast hit, and we're getting information about what the ray is touching. We get the game object of that, and again we're getting the XR grab interactable, because now instead of using select entered, we want hovered entered. So we are trying to hover inside take the ray and hover inside the object. So what this is doing, ray interactors. So now we're actually not doing this. We're actually doing here, hover entered. So as soon as we entered, this is the event that we're going to be activating. So again, so we want to, when we're doing the hover entered, we're getting a listener. So this listener is when that hovering, we're calling this method called hover. So hover method, so what that's doing is, okay, we're using this as an argument, hover enter event args, the argument. So again, from this argument, we're getting information about the interactable object. So whatever is touching the ray, we're getting that information. We're getting the transform position. We're getting the position. But what we're doing with that position, while it's hovering, while it's touching the ray, we're actually making it hover above the ray. So we do that by giving a direction, vector3.up, so that is the y-axis. We're multiplying it by a hover height. So hover height, we defined the value here, hover height, so we can make it bigger or smaller. So right now we set it to 1 floor, so we can make it hover higher or lower. And then we are multiplying that by the cosine function here, the mathf.cosine. So the parameters, we're utilizing the time.time. So this is another built-in Unity function. So time.time is the time from the beginning of this frame. So this current frame only. So we're using that and multiply it by the hover speed. So the hover speed is, again, labeled here, hover speed. So how fast it's actually hovering. And that's how we got that. So so that's how we handle the grabbing, the hovering, and all the forms. So the create lightning bolt, you can look at the script and see how we did that. But I went over the main stuff, like how we hover objects, how we actually grab them, and I did not do any release object because I didn't feel like we needed to. It was really not necessary, but if I wanted to, it would be very similar to what we did with the grab object and the hover object. So I hope this has been very informative and you like the program so far.